So, Jumbo, we're looking elements, electron arrangements, and you should have a sheet that has all kinds of circles on it, looks like bullseyes. We're not going to fill in all of them, so you do have to pay careful attention. Make sure you are filling things in the right spot, or it won't make any sense. The good news is you should already know this stuff from beforehand. We had a wonderful student named Carl Enns, and N's and electrons almost rhyme, so years ago some girls sent me his picture and we turned it into a circle and tried to make it into electrons. He has a message for you that you may read. So we are really worried about electron arrangements in chemistry because they're going to help us explain ultimately chemical reactions, what's going on. So he's reminding you that he's an electron, he has a negative charge, no mass, he orbits the nucleus at high speeds, and he's what's lost or gained when elements, atoms interact with each other. Yeah, things came in a little wackadoodle. So find lithium on that chart. And what you see is lithium is atomic number 3. That means it has 3 protons. So we'd have 3 protons nucleus. And when it's an atom, we're going to have 3 electrons. The first shell can handle up to 2. And then it's full. So the next electron has to go into the next shell. And then if you look at where lithium is in the periodic table, you say, hey, this is making sense. It's in the second period, it has 2 layers of electrons, and it's in group 1, it has 1 outer electron. When you're drawing this, you want to make these nice, obvious dots. They don't have to be this big, and you don't have to draw Carl's face on it. But these are called Bohr diagrams, for the Dane named Bohr, Niels Bohr, who proposed this idea. So group 1, that's where lithium lives, 1 outer electron, and it'll form a 1+ ion. It should say that at the bottom of that column. Right below lithium is going to be sodium. Sodium lives at spot 11. So that means it's going to have 11 protons, and therefore 11 electrons. And here come the electrons, 2 in the first, 8 in the second, 2 plus 8. Now it's full, and so we need a third shell with 1 outer electron. You got to remember, electrons have the same charge, a negatively charged, so they can't be too close to each other. So once we put 8 in the second shell, it's full and cannot handle another. The repulsions will be too great. So that's it for group 1. They all have 1 outer electron, all form 1+ ions. We go to group 2, we're going to look at beryllium. Now we're back to regular dots here. Yours don't have to be different colors. This is reminding us we have 4 protons, therefore we have 4 electrons that we have to find a home for, 2 in the first. And the outer electrons got put in this yellowy orange color, just to show outer electrons, that's what matters. So beryllium typically is going to have 2 outer electrons that it wants to lose. Loses 2 electrons, becomes a 2+ ion. It'll say that underneath this column. Right below beryllium, we have magnesium, and that one came in weirdly. And so we go magnesium spot 12, and so you go 2 in the first, 8 in the second, that's 10, so we need 2 more electrons. Somewhere these electrons are going to appear, there we go. 2 outer electrons. It would like to lose those 2 outer electrons, become a 2+ ion, and that's true if we went down that group all the way down to the bottom. we would find they all form a 2+ ion. Now we look at boron. 2 in the first, 3 outer electrons for a total of 5. It lives at spot 5 electrons. And for our purposes, we have the 3 outer electrons. We're going to say they're going to lose them and form a 3+ ion. Boron, sometimes being like a non-metal, can behave a little differently. We won't worry about that here. Underneath boron, if we're in Canada, we say aluminum. In England, they say aluminium because they have another ion there. And there we have aluminum goes 2 in the first, 8 in the second, 3 in the third, 3 outer electrons. It would like to lose those 3 outer electrons that are colored the orange color. In that case, it would have still the 13 protons, but only 10 electrons. 3 extra protons means 3 extra pluses, which is the charge in that ion. Now you got to pay close attention. We've hopped all the way over to oxygen. So don't go over 1 and go over until you hit oxygen. So you need to have a nucleus. Often we just put the symbol in. We got 2 in the first, and then we're going to have 6 outer electrons. Makes sense. We have 8 electrons, 6 are outer electrons. Oxygen happens to be in group 6. And we say, look at that, it's got a hole right here and a hole right there. It would like to pick up 2 more electrons. The nonmetals gain. And they're gaining electrons. That means they're gaining a negative. If you gain 2 electrons, you've gained 2 negatives and you're a 2 negative ion. Right below oxygen is sulfur. So it's going to look a lot like this. It doesn't matter where we put the gaps in the outer shell as long as they're in the outer shell. And it goes 2, 8, and then 6. Notice group 6, 6 outer electrons. But if you know the group number, you know how many outer electrons there are. And again, just like oxygen, 6 outer electrons, just like oxygen wants to gain 2, become a 2- ion. Now we're going to hop 1 to the right of oxygen, and that's fluorine. And there's fluorine, 2 and 6, and we say, well, that's a problem. We got an electron that's going to need a late slip. There it is. So now we have our 2 and our 7, and this time we have room for 1 more. So 7 outer electrons, fluorine's group 7. It would like to gain 1 electron. It would like to pick up a 1- charge. And this is going to be true for all the halogens. So there's fluorine. Now we're going to look at chlorine and see the same pattern. Here's chlorine, 2, 8, and there's 7 outer electrons, group 7, room for 1 more. And forms a 1- ion when it picks up that 1 extra electron, because hey, it would have 17 protons in the nucleus, picks that up. Now it'll have 18 electrons, 1 extra electron. Now we get to the promised land of the Bruins. And we are looking at the wacky world of neon, named for Cam Neely, the president of the Bruins. This time we got 2 electrons, a little bit tardy. Now, 2 and 8, this is a full outer shell. Group 8 element. It's got 8 outer electrons. It does not need to change, and therefore it does not form ions. So noble gases do not react easily. It's only under extreme conditions you might be able to make them react. Now we go right below. What are we going to find underneath neon? There's argon. And we're going to do the same kind of pattern. Oh, that didn't come in right. Let's try it again. Third time. See if they come in. Okay, we're bowling in the electrons. And you can see we're missing the 2 inner electrons now. They finally show up. Well, at least 1 did. So we've got our 2 in the first shell, 8 in the second shell, and we've got to end up with 8 in the third shell. And this one involves some head squishing. So hopefully it doesn't creep you out too much. But when you add it all up, you have 2 plus 8 plus 8, 18 electrons, no surprise, because argon lives at spot 18. It's got a perfect full outer shell of electrons, like all the noble gases. In this case, 8 outer electrons, does not want to change. It is non-reactive. So when it says does not form ions, that's another way of saying non-reactive. So hopefully this has been a good review of electron arrangements. And remember, you're just drawing dots, you don't have to draw faces.